Hi, Assalamualaikum. My name is Muhammad Anuar bin Muhammad ZAWAWI. Today, I want to present about my FYP1 proposal, Smart Natometer for Bite Force, and my supervisor is TS Dr. Muhammad Azmi bin Abdul Patah. Today, I want to cover a few things, and this is the presentation outline that I will be covering. Introduction, literature review, methodology, and preliminary result for this proposal. So, we will start with the introduction. What are artificial teeth? Artificial teeth, also known as dentures, are prosthetic devices designed to replace lost tooth and are held in place by the soft and hard tissue of the oral cavities. Traditional dentures can be removed. However, there are numerous dentures designs available which are rely on bonding or adhesive to stick to the natural teeth or denture implants. So for the summary of the study is focusing on creating a new type of natometer that is safe to use to measure the maximum denture force. Next, the new natometer is a 3D model created in Fusion 360 and printed on FDM machine with a biodegradable PLA which is safe to use. Next is the prototype measure by force to help create artificial teeth for denture patients. So next we go through the literature review. Based on previous studies, articles, and journals, several studies have developed natometer to measure bite force for occlusal measurement. Previous studies have shown that natometer are harmful to patients' health because they are using hazardous material and they are made of fragile parts that are easily broken. According to M. Bakke, 2006, bite force can be defined as the force exerted by the masticatory muscle upon the occlusal surface of teeth, and the maximum bite force of the natural teeth of healthy adult in the molar area is between 300 to 600 Newton. So, the first literature review is T-scan in digital occlusal analysis. The sensor is made up of columns and rows of pressure-sensitive ink trapped in mylar sandwich. So mylar is a boped polyester film. The force sensitive range is 0.1 to 100 Newton. For this system, there are two analysis mode for this model, which is time analysis mode and force analysis mode. The time analysis mode is for location and sequence of occlusal contact. Meanwhile, the force analysis mode is for location and force of the fluid contact. The advantages of this natometer is that first, the force range value is too small, which is maximum of 100 Newton, and two, the device is too large and hard to set up. Next, the study is the low-cost sensor for human bite. This contraption's bite force sensor is made up for two polyvinyl siloxane PVS, addition silicone layer and acrylic frame, and with a metal strain gauge, and the range of biting force is from 0 to 700 Newton. Also, the system uses a compression machine to take the accurate and reliable result. For the disadvantage of this study is that it is complicated to set up for fabrication and calibration. Next, it requires high-resolution multimeter to detect the resistance changes in a Wheatstone bridge circuit. Next is the in vivo test method using NATO dynamometer. This natometer is made of stainless steel and the force measure is based on the analog scale on the device, which is at the biting point is made of rubber, which is contacted to the main arm for the scaling, and for the maximum force range for this equipment is from 0 to 192.6 Newton. The advantages of the system is that first, it is hard to calibrate the scale, which is inaccurate. Second is the bulky and hard to reach back of the mouth teeth, which is the molar area of the teeth. Third is that it is unsafe due to the sharp edges of the design. Okay, next is innovative miniature bite force recorder. This natometer is made of metallic shaped fork with a strain gauge fixed to one of the fork surfaces. And for the testing phase, they are recorded the force for the both men and women. The maximum bite force for men is 606.8 Newton and the maximum bite force for women is 486.2 Newton. The disadvantages of this type of natometer is that first, it is complicated and hard to fabricate. Second, the dangerousness of this natometer as they are usually metallic shaped prongs. Third is that hard to measure precisely as they are using strain gauge sensor. Therefore, the comparison between previous studies can be made. And to summarize the finding, using strain gauge can produce high force, while it is difficult to calibrate as it is require amplifier and what Wheatstone bridge calculation to calculate the resistance changes. And also, the bite force for each type of the nanometer, it is different based on the material used and it is difficult to calibrate. So this is the problem statement that can be made from the previous study. The common problem being that is that it is hard to calibrate and not friendly user. For the first picture, we can see that the force range value is too small, which is a maximum of 100 Newton, and the device is too large large and hard to set up. For the second picture is that it is complicated setup for fabrication and calibration. It also requires high resolution multimeter to detect resistance changes in the Wheatstone bridge circuits. So for the third picture, we can see that it is hard to calibrate the scale and the bulky and hard to reach at the back of the mouth at the molative area, make it hard to use. The third is that it is unsafe due to the sharp edges and using a metallic material. The fourth picture is that it is complicated and hard to fabricate, dangerous using a metallic shaped prongs, and hard to measure precisely using a strain gauge system. Therefore, for this study's objective, I want to produce an innovative nanometer that is compact, can store data, and it is user-friendly and convenient for the patient. Second is to improve and integrate a new smart nanometer with implication of new component and data storing mechanism. The third is that to implement a better system and mechanism to ease the manufacturing process and reduce the production cost. Next is the scope and limitation. The scope of the study is that I will be focusing on creating a new design for the nanometer and focusing on electronic part by compact components such as Arduino Nano BLE. And the limitation is that first, it is denture strength is the restricted, and the using of PLA plastic material is more brittle than ABS material. Up next, we will go through the methodology of the study. The study consists of three main objectives, and each objective contains a phases. The first objective and phase 1, I will be analyze and study the previous article about the mechanism and system used for that particular study. The second objective and phase 2 is focusing on nanometer production, where I will create a design using Fusion 360, and I also will be using Fusion 360 to do static analysis to mimicking the biting force. Then I'll be start printing the model using a 3D printer and the Pro 3 using PLA filament. Next, for the electronic part, I'll be choosing an Arduino Nano BLE as it comes with a Bluetooth module and to reduce the usage of space. And after that, I'll be assembling all the electronic parts. Finally, the calibration of FlexiForce sensor using different weight to check for the accuracy. Next is the third objective and consists of phase 3 and phase 2. For the phase 3 in vivo experiment, where I'll be measuring the bite force for the human tools, and the phase 4 is data tracking and analysis, where I record the force for the tools and start to tabulate the data. So let's see we go through the preliminary result of this proposal. For the preliminary result of the proposal, I have come up with a design, a static analysis simulation and electronic part needed for the system. For the design, a diaphragm system is used as a tooth placement as it can be bendable without breaking and using a latching mechanism for the mouthpiece to insert the FlexiForce sensor. For the static analysis simulation, the diaphragm is on 450 Newton force, which is standard for human bite force, and based on the simulation, the maximum von Mises stress to break the diaphragm is 4295 megapascal, and there is a lot of force needed to break the diaphragm. Next, for the electronic part, I'll be using an Arduino Nano BLE as it came with a Bluetooth module to maximize the compartment space of the design. Then using a SD card module for the data storage, plus including a LiPo charger module to increase the portability of the device. So this is the design for the nanometer. As you can see, I using diaphragm system for the biting force and the latching mechanism to insert the FlexiForce sensor. Lastly, this is electronic part used for this study. I will be using Arduino Nano BLE voltage sensor to monitor the voltage, 3.7 volt LiPo battery for the power supply, and using the LiPo charger module to charge the battery. Then I'll be using FlexiPOS sensor A301, which is a short and easy to connect. Then I'll be using I2C LCD display to display the biting force. Then lastly, I'll be include the SD card module for the data storage for the system. And that's all from me. And if you have any question, feel free to contact me and I will gladly respond to those questions. Assalamualaikum and thank you. Have a nice day.